In this demo, I'll show you how to apply tune to a general machine learning objective function using GreyKite. This demo means to show tuning on a complex objective and a large search space, so there's no need to read through each line of code. I will highlight the important parts that are most related to our topic. Starting from the objective function, as we can see, GreyKite's objective function is super detail-oriented due to its flexibility. But that is fine. Tune allows users to define the objective function in native Python language, and there's no rules or constraints on how it should look like. All we need is the output model score to evaluate the result, and the rest will be converted by tune to be tune compatible. This is really great because it means that we don't need to modify any of our existing code to use tune. Now let's see how to define the hybrid search space. There are just so many parameters in this forecasting model, but that is totally fine too. We can intuitively define each of them and freely apply a mixed type of tuning methods. For example, here we used Bayesian optimization for tuning the seasonalities and the change point detections. And we used GreySearch for tuning the number of days before and after a holiday. As you can see, even for such a complex and nested search space, we can still define it in an elegant way. Last but not least, in calling just one single function and tweaking its parameters, we can distribute the tuning jobs with Spark and track the tuning result with MLflow effortlessly. Again, we can track the result from running this suggest method and its subruns in the MLflow experiments. As the most recent job is still running, let's look into a finished run. So for each subrun, we can clearly see its best objective metric and all the associated metadata, as well as all the corresponding parameter values. And let's look into one subrun. Here, note how complex is the actual parameter set compared to our clean code of the space definition. And here, let's look into the objective metric. So again, we could see how this objective metric was improved over time by Bayesian optimization.